So the main reason why I got this question wrong was because I assumed a lot of things. I assumed that triangle DAC was an isosceles triangle, and I assumed that the entire quadrilateral was a kite. By assuming that triangle DAC was an isosceles triangle, I assumed that angle DAC was 63 degrees. And by adding up all of the angles that I knew and subtracted it from 360, I assumed that angle D was 54. Using the idea of a perpendicular bisector, I then drew an altitude from angle B to angle D, and assumed that because this was a kite, it would hit length AC and divide it into two equal parts, and bisect angle D into two equal angles of 27 degrees. And this was the part where I mainly made that huge mistake that costed me 4 points, because I could not assume that the altitude that would hit AC and would divide AC into equal lengths would also hit point D as well. And while I did find the length of AC correctly, my assumption that angle DAC was 63 degrees and angle ADB was 27 degrees caused me to find that the length of AD was 7.98, which, when I rounded, equal to 8 degrees. And here, as you can see, I did use the law of sines correctly, but I inputted the incorrect numbers based off of my 3 initial assumptions. Now, however, I do understand that you can use the property of cyclic quadrilaterals in order to find the length of AD. And by adding up all of the angles that I did know and subtracting it from 360, I realized that angle D was in fact 50 and not 54. And thus, using the law of sines, you could substitute in AC for what you found earlier, which was approximately 7.25, in order to find the length of AD. By coincidence, when you round the answer, it just so happens to be around 8, but obviously this is the correct method, as opposed to mine, which I assumed many things that turned out to be wrong.